Hello and welcome to a brand new series of Science Extreme, filmed here in the great outdoors. I'm your presenter Jacob Jones. Here's Brenton Small. Resident Boffer, Mr. Leopolds, who's joining us via webcam.
Hello.
But this episode is very special. It's being filmed in front of a live audience, which consists of James, a picture of Alistair, and a dog. And here's our cameraman, Lawrence Astle. And our director, Sam Drightman.
Action!
We're already rolling.
Carry on.
And here's a montage of what's coming up in this brand new series. In this lesson, we'll be fulfilling these three success criteria. And now to explain the first one is our resident buffer, Mr. Leopold.
I'm Professor Leopold, and today we shall be doing the contact process, of which there are 3 steps. So the first step is to create sulfur dioxide. Now this is through the combustion of sulfur in air, that is S plus O2 makes SO2. Sulfur plus oxygen makes sulfur dioxide. So the second step is creating sulfur trioxide. Now this is a reversible reaction. That is 2SO2 plus O2 makes 2SO3. That is sulfur dioxide plus oxygen makes sulfur trioxide. And so the third and final step is to create sulfuric acid, which is of course the point, if you like, of the contact process. That is SO3 plus H2O makes H2SO4. That is sulfur trioxide plus water makes sulfuric acid. And now over to Jacob, back in the great outdoors, with an inhumanely stupid way of trying to summarize something he doesn't quite understand.
So basically, we take oxygen, burn it, mix it with water, then mix it with oxygen, then dunk it in water. Cut. Cut.
Oh, sorry.
Anyway, to fulfill the second success criteria, here's our resident boffin, Lenford. Because it's especially boring, we'll have some dancing in the side.
Hello again. Equilibrium is the point in a reversible reaction where everything is balanced. This point of equilibrium can be shifted to the left or the right of the reaction. The point of equilibrium is affected by 3 things, that is, temperature, concentration, and pressure. So let's look at temperature first. All reactions are endothermic in one direction and exothermic in the other. So if you decrease the temperature on one side, the equilibrium will be forced to compensate and try and increase it, thus shifting the reaction to the exothermic or right-hand side. So now we move on to pressure. Now remember, this only affects gases. That's right, only gases. So if you try to increase the pressure, the equilibrium will try to reduce it, thus moving the point of equilibrium towards the area with fewer moles of gases. And again, the reverse is also true. And finally, we come to concentration. Increasing the concentration of the chemicals on the left-hand side forces the point of equilibrium towards the right, creating more of the chemicals on the right hand side. And, of course, the reverse is also true.
And here's Leonard with our third and final success criteria.
There are indeed many compromises to be made in the contact process. For example, temperature. You'd think you'd want to decrease temperature as much as possible to shift the point of equilibrium to the right and thus to create more product. But there you'd be wrong, my child. For decreasing the temperature is also decreasing the rate of reaction. It could be so slow you wouldn't even want to bother. So a compromised temperature of about 450 degrees Celsius is used. And then there is pressure. I'd assume you'd want to increase the pressure, to throw the point of equilibrium so far to the right you wouldn't be able to find it, and you'd be have to search for it for days and days upon end. But of course you'd be wrong again. This would be monumentally expensive, and it's not even necessary. The point of equilibrium is already on the right, so atmospheric pressure can be used. And then there is a catalyst. Vanadium pentoxide is its name, V2O5. Now this catalyst does not affect the point of equilibrium, but what it does do is increase the rate of reaction, which I'm sure we'll all agree is very useful.
Well, that was interesting. Don't worry, next week will be better. Speaking of which, coming up next week.
James learns an...
Sorry, can I have a drink of water, please? Next week, James learns a new dance. And the live audience get into a sticky situation. No, back! Foul fiend! And next week, the whole world was destroyed.
Massive boom!